Okay, so good day everyone. I think what we're going to discuss today is about the measures of central tendency or average. Okay, so we may focus on mean, median, and mode. Now, the average scores regularly in our daily life, and it is an important tool in statistics. Okay, a well-chosen average consists of a single number about which a given data are centered. There can be several different types of averages or sometimes called measures of central tendency. And they are the mean, median, and mode. Now, what is a mean? Mean is the average of a set of data. So to calculate the mean, we need to find the sum of the data and then divide by the number of data. So the mean of a set of observation is the average. It is obtained by dividing the sum of data by the number of observation. So this will be the formula. So mean is equal to sum of data divided by the number of observation. So example, so find the mean of the following set of integers. So we have 8, 11, -6, 22, and -3. So this will be the solution. So mean is equal to 8 plus 11. So as what we did, of course, plus -6 plus 22 plus -3. So divide 5 because 8 is 1, 11 2, 6, -6 is 3, 22 is 4, and -3 is 5. So divided by 5. So if we're going to sum up this one, divided by 5, that is 6.4. And this will be the mean. For example, number 2, the set of scores is 12, 5, 7, -8. X, 10 has a mean of 5. Find the value of x. So mean is equal to 12 plus 5 plus 8 plus -8 plus x plus 10. So divide 6, that is equals 5. So 26 plus x is equal to 30. Then x is equal to 4. So I have here the word problems involving mean. When there are changes in the number or values of the observation in a set, the mean will be changed. So the mean score of a group of 20 students is 65. Two other students whose scores are 89 and 85 were added to the group. So what is the new mean of the group of students? So the formula, total score divide number of students. So can written as total score is equal to mean multiplied by the number of students. Then the total score of the original group is equal to 65 times 20 is equal to 1,300. So total score of the new group, total score of the new original group plus scores of the two new students. So 13 plus 89 plus 85, that is equal to 1,474. Then a number of students in the original group plus number of new data. So 20 plus 2 is equal to 22. So mean of the new group is equal to 1,474 divided by 22 is equal to 67. So another example, so the mean of a list of 6 numbers is 20. If we remove one of the numbers, the mean of the remaining number is 15. What is the number what was moved? Using the formula, sum is equal to mean multiplied by the number of numbers. Sum of the original 6 numbers is equal to 20, as what we have here, no? Times 6 is equal to 120. Then sum of the remaining 5 numbers is equal to 15 times 5 is equal to 75. Now, number removed is equal to sum of original 6 numbers minus sum of our remaining 5 numbers. So 120 minus 75 is equal to 45. So what will be the alternative method? So let x be the removed number. So 6 times 20 minus x is divided by 5 is equal to 15. X is equal to 45. So the removed number is 45. Another example, so we have 10 students of a class had a mean score of 70. The remaining 15 students of the class had mean score of 80. So what is the mean score of the entire class? So this will be the solution, and the answer is 76. Okay, this time, please get your yellow paper or coupon band and solve this mean problem example 1 and 2 and send it to our FB private message group. Now, population mean in sample mean. So we have what we call the arithmetic mean, It is the average of a group of numbers and is computed by summing all numbers and dividing by the number of numbers. So this will be the formula for population mean and the formula for sample mean. So when we say population, it is a collection of persons, objects, or items of interest. When we say sample, is a portion of the whole, and if properly taken, is representative of the whole. As what we discussed in our practical research 1. The population mean is represented by Greek letter, of course, and it is given by the formula. So this will be the formula for the population mean. Now, so the sample mean is represented by X bar, of course, it is given the formula, and N is the number of number of terms in the sample. So how about median? So median, arrange the observation in ascending order. So number of observation is add, for example, add numbers. So like 3, 5, 7, 9. So number of observation, the median is in the middle value, which is at position. So n plus 1 over 2. Well, the number of observation is even, like 2, 4, 8, 16, 32, and so on. The median is the average of the two middle values. Okay, so this will be the procedure. So example, find the median of the following set of points in a game. So 15, 14, 10, 8, 12, 8, 16. So the first is, of course, you need to rearrange. Okay, so it will become 8, 8, 10, 12, 14, 15, 16. So the number of point values is 7. So 1, 2, 3, 4, 5, 6, 7. As what we discussed earlier, so if it is an odd number, look for the center or the middle. So 1, 2, 3, 1, 2, 3. So therefore, 12. The number of point values is 7. So an odd number. So it's the median value of the middle position is 12, as what we have here. Another example, so 15, 14, 10, 8, 12, 8, 16, 13. So again, rearrange, but by this time, the number of point value is 8. Okay, so in that is an even number. So what we're going to do is just to get the two center, that is 12 plus 13, divide 2, that is 12.5. Okay. So another example. So x is the median for 4, 3, 8, x, and 7. Find the positive values of x. So arrange the numbers in ascending order with x in the middle. So this tell us that the possible values of x are 4, 5, 6, and 7. Now, so another example, 7 mothers were selected and given a blood pressure check. So their systolic pressures were recorded as, as stated. So we had 1, 2, 3, 4, 5, 6, 7. So therefore, arrange the data in the order, then select the middle value because add number. For the even number, so we have 1, 2, 3, 4, 5, 6, 7, 8. So what we're going to do is to get the center. So that is rearrange first. Then after rearrange, get the two center. So that is 407 and 415. $398, 400, 402, 407. I forgot to write another 415, right? Okay. So 407 and 415, find the median by getting the mean of these two values. Okay, so 407 plus 450 should be by 2. That is 411. Our median for this problem is 411. What is the mode, median, mean? So in statistics, mode, median, and mean are typically values to represent a pool of numerical observation. They are calculated from the pool of observation. So mode is the most common value among the given observations. Okay, well, the median is the middle value and the mean is the average of all values. So this will be the average value for mean, the middle number is for the median. The most frequent number for mode in range is difference between highest and lowest numbers. It's too easy actually to find the range, okay? So, and this will be the procedures or the steps on how we'll be able to get the mean, median, mode, and the range. The example for the mode. The mode of a set of observation is the value that occurs most frequently in the set. A set of observation may have no mode, one mode, or more than one mode. So example, so 11, 14, 15, 9, 11, 15, 11, 7, 13, 12. So the mode is 11 because 11 occurred more times than the other numbers. If the observation are given in the form of a frequency table, the mode is the value that has the highest frequency. Okay? So for example, the first one is 3, 3, 2, 2, 15, 2, 3, for example, 2, 3, 4. So if the highest frequency is this one, therefore our mode is this one, since this is the highest frequency, 35. So another example, find the mode of the following set of marks. So the marks 2 and 3 have the highest frequency, right? 7, 7. So therefore, the modes are 2 and 3. The above example shown that a set of observation may have more than one mode. Another example. So find the mode for each of the following frequency table. So we have weight, bag, and bags of rice. Then there are 8 numbers card with 0 to 7. Each time a card is drawn at random at the value card value is recorded, the frequency refers to the number of times a value is shown. So this will be the solution for A. This will be the A, and this will be the C, or B rather. Okay, so I will show you a video presentation about the mean, median, and mode discussion.
Hi, this is Rob. Welcome to Math Antics. In this lesson, we're going to learn about 3 important math concepts called the mean, the median, and the mode. Math often deals with data sets, and data sets are often just collections or groups of numbers. These numbers may be the results of scientific measurements, or surveys, or other data collection methods. For example, you might record the ages of each member of your family into a data set. Or you might measure the weight of each of your pets and list them in a data set. Those data sets are fairly small and easy to understand, but you could have much bigger data sets. A really big data set might contain the cost of every item in a store, or the top speed of every land mammal, or the brightness of all the stars in our galaxy. Those data sets would contain a lot of different numbers, and if you had to look at a big data set all at one time, it would be pretty hard to make sense of it or say much about it besides, well, that's a lot of numbers. But that's where mean, median, and mode can really help us out. There are 3 different properties of data sets that can give us useful, easy to understand information about the data set so that we can see the big picture and understand what the data means about the world we live in. That sounds pretty useful, huh? So let's learn what each property really is and find out how to calculate them for any particular data set. Let's start with the mean. You may not have ever heard of something called the mean before, but I'll bet you've heard of the average. If so, then I've got good news. Mean means average. Mean and average are just 2 different terms for the exact same property of a data set. The mean, or average, is an extremely useful property. To understand what it is, let's look at a simple data set that contains 5 numbers. As a visual aid, let's also represent those numbers with stacks of blocks whose heights correspond to their values. 1, 8, 3, 2, 6. Right now, since each of the 5 numbers is different, the stacks of blocks are all different heights. But what if we rearrange the blocks with the goal of making the stacks the same height? In other words, if each stack could have the exact same amount, what would that amount be? Well, with a bit of trial and error, you'll see that we have enough blocks for each stack to have a total of 4. That means that the mean, or average, for our original data set would be 4. Some of the numbers are greater than 4, and some are less. But if the amounts could all be made the same, they would all become 4. So that's the concept of the mean. It's the value you'd get if you could smooth out or flatten all of the different data values into one consistent value. But is there a way that we could use math to calculate the mean of a data set? After all, it would be very inconvenient if we always had to use stacks of blocks to do it. There's gotta be an easier way. To learn the mathematical procedure for calculating the mean, let's start with blocks again. But this time, instead of using trial and error, let's use a more systematic way to make the stacks all the same height. This way involves a clever combination of addition and division. We know that we want to end up with 5 stacks that all have the same number of blocks, right? So first, let's add up all of the numbers, which is like putting all of the blocks we have into one big stack. Adding up all of the numbers, or counting all the blocks, shows us that we have a total of 20. Next, we divide that number, or stack, into 5 equal parts. Since the stack has a total of 20 blocks, dividing it into 5 equal stacks means that we'll have 4 in each, since 20 divided by 5 equals 4. So that's the math procedure you use to find the mean of a data set. It's just 2 simple steps. First, you add up all the numbers in the set, and then you divide the total you get by how many numbers you added up. The answer you get is the mean of the data set. Let's use that procedure to find the mean age of the members of this fine-looking family here. If we add them all up using a calculator, or by hand if you'd like, the total of the ages is 222 years. But then, we need to divide that total by the number of ages we added, which is 6. 222 divided by 6 is 37. So that's the mean age of all the members in this family. Alright, that's the mean. Now what about the median? The median is the middle of a data set. It's the number that splits the dataset into 2 equally sized groups or halves. One half contains members that are greater than or equal to the median, and the other half contains members that are less than or equal to the median. Sometimes finding the median of a dataset is easy, and sometimes it's hard. That's because finding the middle value of a dataset requires that its members be in order from the least to the greatest, or vice versa. And if the dataset has a lot of numbers, it might take a lot of work to put them in the right order, if they aren't already that way. So to make things easier, let's start with a really basic dataset that isn't in order. It's pretty easy to see that we can put this dataset in order from the least to the greatest value just by switching the 2 and the 1. There, now we have the dataset 1, 2, 3, and finding the median or middle of this dataset is easy. It's just 2, because the 2 is located exactly in the middle. That almost seems too easy, doesn't it? But don't worry, it gets harder. But before we try a harder problem, I want to point out that sometimes the mean and the median of a dataset are the same number, and sometimes they're not. In the case of our simple dataset, 1, 2, 3, the median is 2, and the mean is also 2, as you can see if we rearrange the amounts or follow the procedure we learned to calculate the mean. But what about the first dataset that we found the mean of? We determined that the mean of this dataset is 4, but what about the median? Well, the median is the middle, and since this dataset is already in order from least to greatest, it's easy to see that the 3 is located in the middle since it splits the other members into 2 equal groups. So for this dataset, the mean is 4, but the median is 3. So to find the median of a set of numbers, first you need to make sure that all the numbers are in order, and then you can identify the member that's exactly in the middle by making sure there's an equal number of members on either side of it. Okay, so far so good. But some of you may be wondering, what if a dataset doesn't have an obvious middle member? All of the sets we've found the median of so far have an odd number of members. But what if a set has an even number of members, like the dataset 1, 2, 3, 4? There isn't a member in the middle that splits the set into 2 equally sized groups. If that's the case, we can actually use what we learned about the mean to help us out. If the dataset has an even number of members, then to find the median, we need to take the middle 2 numbers and calculate the mean or average of those 2. By doing that, we're basically figuring out what number would be exactly halfway between the 2 middle numbers, and that number will be our median. For example, in the set 1, 2, 3, 4, we need to take the middle 2 numbers, 2 and 3, and find the mean of those numbers. We can do that by adding 2 and 3 and then dividing by 2. 2 plus 3 equals 5, and 5 divided by 2 is 2.5. So the median of the dataset is 2.5. Even though the number 2.5 isn't actually a member of the dataset, it's the median because it represents the middle of the dataset and it splits the members into 2 equally sized groups. Okay, so now you know the difference between mean and median, but what about the mode of a dataset? What in the world does that mean? Well, mode is just a technical word for the value in a dataset that occurs most often. In the data sets we've seen so far, there hasn't even been a mode because none of the data values were ever repeated. But what if you had this data set? This set has 6 members, but some of the values are repeated. If we rearrange them, you can see that there's 1 1, 2 2s, and 3 3s. The mode of this data set is the value that occurs most often or most frequently, so that would be 3 since there's 3 3s. Now don't get confused just because the number 3 was repeated 3 times. The mode is the number that's repeated most often, not how many times it was repeated. As I mentioned, if each member in a dataset occurs only once, it has no mode. But it's also possible for a dataset to have more than one mode. Here's an example of a dataset like that. In this set, the number 7 is repeated twice, but so is the number 15. That means they tie for the title of mode. This set has 2 modes, 7 and 15. Okay, so now that you know what the mean, median, and mode of a dataset are, let's put all that new information to use in one final real-world example. Suppose there's this guy who makes and sells custom electric guitars. Here's a table showing how many guitars he sold during each month of the year. Let's find the mean, median, and mode of this dataset. First, to find the mean, we need to add up the number of guitars sold in each month. You can do the addition by hand or you can use a calculator if you want to. Either way, be careful since that's a lot of numbers to add up and we don't want to make a mistake. The answer I get is 108. So that's the total he sold for the whole year. But to get the mean sold each month, we need to divide that total by the number of months, which is 12. 108 divided by 12 is 9. So the mean, or average, is 9. Next, to find the median of the dataset, we're going to have to rearrange the 12 data points in order from smallest to largest so we can figure out what the middle value is. There, that's better. Since there's an even number of members in this set, we can't just choose the middle number. So we're going to have to pick the middle 2 numbers and then find the mean of them. 9 and 10 are in the middle since there's an equal number of data values on either side of them. So we need to take the mean of 9 and 10. That's easy. 9 plus 10 equals 19, and then 19 divided by 2 is 9.5. So the median number of guitars sold is 9.5. That means that in half of the months he sold more than 9.5, and in half of the months he sold less than 9.5. Last of all, let's identify the mode of this data set, if there is one. Well, let's see. There's 2 8s in the data set. Oh, but there's 3 10s. That looks like the most frequent number. So 10 is the mode of this data set. It's the result that occurred most often. All right, so that's the basics of mean, median, and mode. There are 3 really useful properties of data sets, and now you know how to find them. But sometimes the hardest part about mean, median, and mode is just remembering which is which. So remember that mean means average, median is in the middle, and mode starts with MO, which can remind you that it's the number that occurs most often. Remember, to get good at math, you need to do more than just watch videos about it. You need to practice. So be sure to try finding the mean, median, and mode on your own. As always, thanks for watching Math Antics, and I'll see you next time.
You're looking smart as always. How is everyone? How's the baby?
Okay, so we're done with the example and video presentation of the mean, median, and mode. So now, mean, mode, and median from frequency table. So as a while ago discussed already by the video presentation, again, we have for group data right this time. Okay, so we have mean, multiply midpoints by frequencies and add the subtotal. Then divide by the total of the frequency. For the mode, find the largest frequency, and the corresponding value is the modal value or modal class. For the median, calculate a running total of the frequencies, and the first interval that is above half the total contains the median. So again, please do watch this video. So this will be my references. Before I proceed to this one, I just want to show another video.
And you divide by the number of data items. In this screencast, we're going to look at the mean from the frequency table, the mean from a frequency table with interval data, the mode from the frequency table, and the median from the frequency table. The mean, just a reminder, to find the mean, it's the total of the data and you divide by the number of data items. So for instance, for 12 young people at a McDonald's party, you would find the total of their ages, which is 142, and you would divide by 9 and you get 15.8 when you round off to the one decimal place. There's another way of finding that total. You could write 12 times 3, 15 times 1, plus 17 times 2, plus 19 times 3. Those numbers, the 3, the 1, the 2 and the 3, are effectively like frequencies. There were 3 12-year-olds in the group. That leads us quite nicely into the idea of using a frequency table to find the mean. Here's some data of the kind you might find in an exam question. A small company was monitoring absence for a 3-month period, and 12 staff had no absence at all, 14 staff had 1 day away, and so on. The days absent is the variable, that's what you're trying to find the mean of. The number of staff is the frequency. You've got to spot which one's acting as the frequency and which one's the variable, otherwise the question becomes impossible to answer. Now remember what we did with the ages of the children. We're now going to multiply each number of days absence by the number of staff that were absent for that period. So nothing times 12 is nothing in the first column, 1 times 14 is 14 in the second column, and so on. Those subtotals we can then add up to find 186 days of absence. But we have to add up the number of staff, the frequencies, to work out how many people were taking the time off. So the mean is 186 divided by 78, and that comes to 2.38, just over 2 days. With interval data, here's some interval data. We do something slightly different. Suppose this was the height of cress plants grown on one of those bits of blotting paper. Mine never used to work, they used to go mouldy, but you get the idea. We can again multiply the height by the frequency, but the height's in intervals, so what we do is we take the midpoint of an interval. So you see how the first interval goes from 10 to 15 millimeters? Well, halfway is 12.5. You can add the 10 and the 15 together, press equals and divide by 2 if you want, or just split the difference. The second interval has a midpoint of 17.5. Now you see how the pattern repeats again for the third and fourth intervals. That's quite common. Well, now we treat the midpoint as if it's actually the data item, and we multiply the frequencies. So you see 7 12.5s is 87.5, well I sincerely hope it is. 12 17.5s is 210, and so on. Just like the first example, now we add up the subtotals, and we add up the frequencies first to find the number of plants we got, then we add up the subtotals. And the mean is given by the total length of all the cress seedlings put end to end, which is 717.5 millimeters, quite a long bit of cress, divided by 37 cress seedlings, and you get 19.4 millimeters as the average height, or mean height. So you see the idea. The main idea is to get the midpoints and then multiply them by the frequencies. On exam questions on tables like this, some of the values are quite often filled in, so you can usually work out what's going on. The mode. The mode's kind of one of the simplest averages. You're basically looking for the most common value in a data set, the one with the highest frequency that translates into. So here's our cress seedling data. The one with the highest frequency is the 15, so we can say that the 20 smaller than height, smaller than or equal to 25 millimeters, is the modal class. You can't actually say any more than that, you can just say that is the modal class. The absence data, because it's discrete data, we can be a bit more accurate about this. We can say that 19 people were absent for 2 days, and that's the largest frequency, so 2 days was the most common absence period. So that's 2 days modal absence compared with 2.39 average, mean average. Okay, that's all there is to say about mode. The median is slightly more complicated. Remember that the median is the value of the middle data item when you put the data in order of size. Well, of course, a frequency table does put the data in order of size. So the smallest seven crest seedlings are in the first interval. So what we do is we find out the total of all the crest seedlings. That came to 37. Then we halve it. That's 18.5. So then we find a cumulative frequency total of all the frequencies. So you see how in the second column we've got 12 plus 7 makes 19. In the third cumulative frequency space you've got 15 plus 19 makes 34. And in the fourth cumulative frequency space you've got 3 plus 34 makes 37. So that cumulative frequency row is like a running total of the frequencies. We'll talk more about cumulative frequency later. Now, which cumulative frequency is the first one that's just higher than 18.5? Well, the answer is it's 19. And that means that the median crest seedling is somewhere in the 15 to 20 interval. We can't say precisely where. It's probably near the 20 end, but we don't know how the crest seedlings are broken down through that interval. So to recap, you take half the total number of things that you have, you do a running total of the frequency, and you find the first one that's over halfway, and then you read off the interval. Applying the same ideas to the absence data, we do the total, that's 78. Half of 78 is 39. Remember 39. Now we do our running totals. What's the first number in the cumulative frequency row that's just bigger than 39? Well, the answer is 45. So that's the column which contains the median value, and the median number of days absent was 2 again. So we had 2 for the median, 2 for the mode, and 2.39 for the mean. Summary. To find the mean, you multiply the midpoints by frequencies and add the subtotals that you get. You divide by the total of the frequencies to find the mean. Mode, you find the largest frequency, the corresponding value is the modal value or modal class. Don't fall into the trap of writing down the frequency as the answer. The median, you calculate a running total of the frequencies, and you find the first interval where the cumulative frequency is just over half the total of the frequencies, and that interval contains the median. Your turn. Any GCSE maths textbook will have a load of questions about this topic because it's a perennial favourite. Work your way through a good chunk of those questions, and there'll be certain edge cases, certain unusual problems that you're asked to solve that will help clarify the issues. And that's it.
Okay, so another example for another video presentation for you to be more
Two. Yan ay 9.65. Mode at saka median ng data set natin. Ito yung data set natin. Okay? So, tinatawag ito siyang data row kasi hindi pa ito siya na-arrange. No? Nakasulat lang as sa row. Kaya tinatawag siyang data row. Okay. So, unahin natin i-solve yung mean nito. No? Okay. So, ano ba yung formula for mean? So, yung formula para sa mean, x bar equals to summation of x values over number of data value. Okay, yung x bar natin ngayon ay equal lang sa summation of x values. Okay? Ano bang ibig sabihin ng x values? Ang ibig sabihin niyan, ito ay x1, x sub 2, x sub 3, x sub 4. So on. So, ibig sabihin niyan, sa madaling salita, i-plus 7 plus 7.0 plus 6.2. Plus, dito na lang sa baba, plus 7.2 plus 5.4. Ito ay division yung function nito, no? Divide. Ano dapat yun nandito? Dito banda sa baba. Yung number of data value natin. Okay? Bawat isa dito ay tinatawag na data value. So, bilangin natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Data value natin ay 12. Kung wala kayong mga scientific calculator, mag-search lang kayo sa Google. I-type nyo lang scientific calculator. So, kunin muna natin yung summation ng lahat ng data. 7.0 o di kaya sabihin natin 7 na. That's equal lang naman sila. 6.2 So, maging maingat ka lang, no? Okay? Check natin kung ito ba talaga lahat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yung summation nito ay 79.6. So, pwede natin i-round off, pero wag muna. Mas mainam na mag-round off tayo sa final answer na. Meron tayong 79.6 divide 12. Okay? 79.6 divide 12. So, meron tayong 6.63333. So, okay lang na isang 3 lang yung kukunin natin. So, ibig sabihin ito ay equal lang sa 6.63 or pwede natin i-round off. Okay? Kasi ito is greater than 5, yung 6. Okay? Kaya pwede natin i-round off dito. No? Para maging 7 yan. So, mag-round off tayo, kailangan equal sa 5 or greater than 5. So, pwede natin i-round off yun sa previous number. Ang mean ng earthquake's strength is 6.63 or 7. Ngayon, isa-solve natin yung median ng earthquake strength. Take note sa median pag ungroup data. So, nakalimutan ko sabihin, no? Ungroup data pala yung sinusolve natin. Yung kinocompute natin is ungroup data. So, sa median, pag ungroup data, merong dalawang cases. So, para makuha natin yung median ng data. Una is, kapag ito ay yung number of data natin, yung number of data value, pwede kayo number of observation, number of participant. Merong dalawang cases. Una, kapag add yung number of data values natin, okay, kapag add number, yung dami nila, ibig sabihin automatic na yung nasa gitna, yun yung median, kapag na-arrange na yung data natin. Okay? Kapag even naman, Kapag even, kunin natin yung midpoint ng dalawang nasa gitna. So, sa case natin, bilangin natin kung ilan ba yung number of observation natin. Number of data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yung number of observation natin is 12. Step 1, kailangan natin i-arrange yung data set natin. Okay? Pag sinabi natin data set, ito lahat ay tinatawag na data set. Okay, yung step 1, kailangan natin i-arrange yung data natin. From lowest to highest or highest to lowest. So, pili lang kayo kung saan kayo comfortable. Pero ako magsisimula ako sa lowest. So, ano ba yung lowest value data dito? 54. Sunod is 6.2. Right? Dalawang 6.2. 6.2. 6.2. Kasunod ay 6.4. 6.4. 6.4. 6.4. Dalawa pala yung 5.4. Sorry, no? So, dalawa yung 5.4 natin. Ang kasunod is 6.5. So, merong isa dito, 6.5. Sunod sa 6.5 ay 7.0 o di kaya 7. Sunod ay 7.2. Dalawa yung 7.2 natin. So, natira na lang is 7.7. At saka yung 8.0. So, ngayon, na-arrange na natin yung data natin. Kapag na-arrange yung data natin, tinatawag siyang arrays data. Okay? Kapag hindi siya arrange, nakalista lang, pero hindi siya naka-arrange, tinatawag na row data. Pero kapag na-arrange na siya, lowest to highest or highest to lowest, tinatawag na arrays data. Yung number of observation natin is 12. So, meron tayong dalawa. No? Dalawang nasa gitna. Meron tayong dalawang value na nasa gitna. Yung dalawang value na nasa gitna is 6.4 at saka 6.5. Okay? Bakit nasabi ko na 6.4 at saka 6.5 yung nasa gitna? Bilang natin. 1, 2, 3, 4, 5. 6. Dito. 1, 2, 3, 4, 5, 6. Step 2, kunin natin yung midpoint ng dalawang nasa gitna. Kung ano man yung magiging result niyan, yan na yung median natin para sa data set ng earthquake strengths. MD stands for median. Okay, equal lang sa 6.4. Okay, dyan nang galing yung 6.4 plus 6.5. So, ngayon, i-divide natin sa 2. Okay? 6.4 plus 6.5. Divide. So, take note pala, sa paggamit ng calculator, dapat maging may ingat kayo. Okay? Katulad nito. I-plus ko yung 6.4 plus 6.5. Tapos, nag-enter ako ng division without putting a parenthesis both side of 6.4 plus 6.5. So, ano kayo magiging result niya? Okay? Divide 2. Yan ay 9.65. Okay? Yan ba ay parehas lang sa ganito? 6, lagyan ko ng parenthesis. 6.4 plus 6.5 parenthesis divide 2. So, saan yung divide 2? I'm sorry. divide 2. So, saan yung tama? Di ba, kanina, without parenthesis, yung sagot is 9.65. So, ngayon, nilagyan ko ng parenthesis, ang sagot is 6.45. So, saan yung tama? Ito yung tama, yung pangalawang ginawa ko. Yung second method na ginawa ko. Okay, lagyan mo ng parenthesis. Kasi magkaiba yung ibig sabihin mo. Yung sagot natin is 6.45. Ma-round off na natin. Pwede natin i-round off yung 5 sa 4. Kasi nga, equal lang sa 5. Okay? So, kailan tayo pwede mag-round off? Kapag 5 or greater than 5, pwede natin i-round off sa previous digit. Or, 6.5 yung median natin. Pero, I don't think na pwede natin i-round off kasi nga median yung hinahanap natin. Kasi pag i-round off natin, ibig sabihin na dito yung median. I don't believe na nandyan yung median. Nandito yung median. Okay? Nandito yung 6.45. Yung dito. Okay? Hindi natin masabi na 6.4. Nandito. So, hindi pwedeng, hindi yan yung median. Hindi yan yung nasa gitna ng data. Dito, sa tingin ko is mas mainam na huwag kayong mag-round off. Kasi nga median yung hinahanap natin. Kasi pag ni-round off mo nga, magiging 6.5. Then, ito yung median. So, that is false. Ngayon, hanapin natin yung mode ng earthquake strength. No? Ito yung halimbawa kung paano maghanap ng mode. So, sa mode nga pala, hindi natin kailangan gumamit ng formula. Pwede kang mag-compute. Hindi katulad sa mean and median, kailangan mag-compute yung data. Take note, itong mean, median at saka mode. Ito yung tatlong paraan kung paano maghanap ng average ng bawat data. Kaya nga sila tinawag ng measures of central tendency kasi naghanap tayo ng center, yung center ng data. So yun yung purpose kung bakit kailangan natin pag-aralan itong mean, median, and mode. Mode is defined as the value that appears most frequently. Sa madaling salita, ano ba yung value dyan na laging nakikita? Pinakamarami. So, yun yung mode natin. Pero, meron tayong iba't ibang klase ng mode. Una, tinatawag na unimodal. Okay? Tinatawag ng unimodal. Only one value that appears most frequently. Example, meron tayong data set na okay, yung mode natin dyan, ano ba yung value na laging makikita dyan? Itong 2. Itong 2. Ito yung may pinakamarami. Compare sa 1, dalawa lang. Okay, kaya hindi natin masabi na mode. Ito yung mode niya. Value that appears most frequently. Sa bimodal, dalawa ang mode natin. Yung tawag na bimodal. Example 1. This time, as you can see, parehas na dalawa yung 1 at saka yung 2. Okay? Kaya tinawag silang bimodal. So, yung mode natin ngayon is 1 and 2. So, pag sinabi natin multimodal, kapag more than 2. Pag more than 2, yung mode natin tinatawag na multimodal. So, tingnan daw natin itong earthquake strength. Kung ano ba yung mode niya. Pwede din natin i-arrange yung data from lowest to highest or highest to lowest. Pero hindi necessary na i-arrange natin yung data. Pero, mas maganda pa rin pag i-arrange yung data. Okay, so ito na nga yung arrangement ng data from lowest to highest. So ngayon, ano ba yung mode natin dito? Okay, check natin. Then, meron tayong dalawang 5.4, dalawang 6.2. So, dalawa rin yung 6.4. Ano pa kaya? Dalawa din yung 7.2. Ibig sabihin, meron tayong multi-modal. Yung mode nito ay 5.4, 6.2, 6.4, and 7.2. So, ganyan lang maghanap ng mode.
I'm Anil Kumar, sharing with you a very interesting video on
So once again, this will be our references. So I hope that you will be able to relearn and learn about the mode, median, and range for this topic. So thank you and good luck to the next topic. God bless everyone.